Hello and welcome back to Algebra for Beginners, Lesson 2 at JK Math Academy. Finding the prime factors of a number is one of the important concepts that we need to know before we even look at least common multiple or what is called as LCM. So we will see a few examples of prime factors again before we delve into the LCM concept. And also at the end we will just see a few examples of how to convert English problems, means problems that are explained or given to us in word form, English sentences form, and we have to convert them to algebraic equations to evaluate them. Before going into learning how to do least common multiples and work on examples, let us revisit the prime factorization for a minute. We'll just use one single number 252 and find the factors of that. See how I'm finding it here. I'm starting with the smallest number always, 2. 252 divided by 2, and then I'm going like that. This is how I suggest you to go to also, because it's easy. Any even number can be divided by 2 and we can go that way till you can't divide it by 2, and then you can go by 3. For example, this can never be divided by 2, nor this can be divided by 2. So that's how I suggest you to go. In the beginning you will not see, at least in classes, you will not see numbers bigger than these kind of things actually, but in the real world how to do, we will see. And so we got the factors. Really speaking, I just mentioning here, please read these slides. 1 and 252 are also factors for this 252, but we don't need them when we are working with LCM, so we ignore them actually. So this is what is the factors we need to work with LCM. See one example where it demonstrates that everything is not going to be as easy it was when we are finding factors, small numbers. Here there is an odd number, but we don't know if it's a prime, but we know it doesn't divide by 2. So the only option for us is to, unless you know what times what is 253, which is very difficult to remember in our minds. So the only way to go on doing this is different numbers, but ultimately you will figure out that 11 and 23 are the only numbers that divide 253 evenly. So the factors are 11 and 23 actually. So this is a slightly difficult example. I would recommend that you should know that these kind of things are also there. It's not that always an easy one. So time consuming things, if you know your tables little bit better, you can handle these little bit easily. This slide is just to demonstrate that there are multiple names that are used for this. So you can read through this. I don't want to spend time honestly wasting. And normally it is called as LCM, the least common multiple. But what exactly is that is the smallest positive integer, the smallest number that is a multiple of 2 or more numbers. We are here talking only about one number as of now, but it could be for multiple numbers, and we'll be seeing examples of 2 numbers very soon. Examples are the best way to learn always actually. So I'm going to show you examples. And why do we need an LCM? We need an LCM when we are solving problems that contains fractions with different denominators. We will see those slowly, but for now let us talk about how to find LCM only. First, LCM is not an algebra concept. This is an arithmetic concept. Second, as I told you earlier, to use square rule books, always use a paper that is having squares like this, which will be very easy for these kind of problems and many more problems in the future in algebra. So let us see what is the LCM of 12 and 18. When something like this has to be done, when we have to find an LCM, the first step in that is to find the product of each of these numbers, 12 and 18. Now that we know how to find products, so we find the products as 2 times 2 is 4 times 3 is 12. And 2 times 3 times 3, 2 times 3 is 6, and 6 times 3 is 18. That's how we find the products. So we got the products or the prime factors of 12 and 18. The way you organize these is, each one of these, for example, if you see 2 and 2 here, this has no 2 in this, so it will not have anything in this column. This has a 3 and this has also a 3, so we do this. This has an extra 3, like this one had an extra 2 and we didn't put anything here. We have an extra 3 here and we don't put anything here. Then what we do is we take 1 2 for this, 1 2 for this, 1 3 for this, and 1 3 for this. That's how we come out. We only take one of the common multiple from both of them actually. If there were more, we will see later, but for now, two numbers we are dealing with, and you will take only these. And when the product of these are called, this is called as LCM. 2 times 2 is 4, 4 times 3 is 12, and 12 times 3 is 36. 36 is considered the LCM of 12 and 18. What does that mean? 12 and 18 can go evenly into 36, which is the lowest number, the smallest number that 12 and 18 can go evenly in a single number. That is what it is. There is no other number less than 36 where 12 and 18 can go. There are bigger numbers. Definitely, if you double this to 72, these will go in that. But we are finding out the least common multiple. So 12 times 3 is 36 and 18 times 2 is 36. Where we will do this or use this, we will see. Here our focus is on finding the LCM, and this is how I would suggest you to learn LCM. That is very important. Otherwise, you will get confused by writing on plain paper or iPads or things like that. I would suggest use a square rule paper to do this. Another example for 9 and 12. How do we find the LCM of 9 and 12? We have to again find the least smallest number where 9 and 12 can divide evenly. That is the requirement. So 3 times 3 is 9. So those are the products for 9. For 12, we have 3 times 2 times 2. 3 times 2 is 6 and 6 times 2 is 12. And now again the same way as we did here, we take only one of these to get the number here. This is the number we want, but we'll take only once. For 9 we got a 3 and for 12 we got a 3, but we'll take only one of them. But for 9 we had 2 3's, but there is no 2 3's here, so we will take only one of them. Same way, there is no 2's at all for 9, and we take only the 2's which are one time here. Then when you multiply these, you will get 36. 3 times 3 is 9, 9 times 2 is 18, and 18 times 2 is 36, which is the lowest or the smallest number where 9 and 12 can divide evenly. That is the purpose of this whole thing. It is a coincidence that in both these cases the LCM is 36. There is nothing to do with that. So, and here is an exercise I want you to do on your own. Please follow these steps. Please do these also yourself first for 9 and 12 and 12 and 18, and then come to this 18 and 24. I given the answer, but don't look at the answer to find the LCM. In the real world, if we have to represent a real world situation in an algebraic form, we can discuss with the business people n number of times and come to the right way of describing things. But when it comes to classes and tests, specifically when you are in middle school and high school and college, you will be asked to do word problems. You have to convert a problem that is explained in English, plain English, into an algebraic notation to work with. Here we are starting off with that. At every stage, I will be definitely working with some English phrase questions, English language questions, which we have to convert it into algebraic notation. Now, for example, let us take these ones. 8 times the sum of x and y. We have to understand this, how to do this. 8 times the sum of x and y. So there are two things I can see here. One is 8 times, means you are multiplying something with 8. 8 times the sum of x and y. That means x and y you add and then multiply it with 8. So how do I represent that? X plus y, and then I multiply it with 8. We have seen this kind of a notation earlier. So when a number is before a bracket, that means it is multiplied with whatever is the ultimate value of this x plus y. So that's how you represent 8 times. This is what it is saying, 8 times multiplying this sum of x and y. See, let us see another one. The sum of 8 times x and y. the sum of 8 times x and y. How do I see this? I'm just doing in front of you. The sum of 8 times. See, here is where you have to be clear. The sum of is 1. 8 times x and y. That is what he is trying to say. The sum of 8 times x and y. 8 times x plus y is what we have to do. So that is what we are trying to do here. 8x plus y. 8 times x first. See, that is what he is saying here. We have to understand. Set 8 times x plus y. Let's see this one. 4 times the sum of p and q. This is almost same like the first one. 4 times the sum of p and q. Yes, the sum of p and q is multiplied 4 times. That is what this means. So first we add p and q and then we multiply it with 4. I think this is also same. The sum of 4 times p and q. The sum of 8 times x and y here. The sum of 4 times p and q. This is exactly similar to the second problem. And the sum of 4 times p, the sum of 4 times p and q. So first multiply 4 and p and then add it with q. That's how it means. Try out these yourself first. Everything when I say, even the examples we are saying, don't see the answers and try out yourself and then do the exercises. I didn't want to give the answers here because if I give the answers, that's all we need to do in these things. So try to convert these, the difference of 2 times x and 8 and 2 times the difference of x and 8 into an algebraic equation. In this session, we revisited the factorization concept, which is one of the fundamental requirements to work with LCM. And then we also saw the initial examples for how to convert English phrases into algebraic expressions. We will continue with them and in the next sessions. And if you really like these sessions, please like, share and subscribe. I'm also making these sessions as short and crisp as possible so that we cover 1 or 2 aspects in a session. Thank you.